Welcome back to track one, the only track at this current time, which is why this is so full. We have Ewen here, software developer from the Waikato, come to give us a field guide to long-lasting software. Please join me in giving Ewen a warm hand.
Good morning, JSCon. My name's Ewen Cumming, and as mentioned, I'm here to talk about long-lasting software today. So, hands up, who's excited by long-lasting software? Okay, that's more than I was expecting, so that's good. Hands up, who's excited to never have to maintain software that they hate? I mean, I thought you guys would have been punching the air, yelling, but you know I can't really deliver on that promise, so good enough. So I've worked in the web space for over 15 years on a number of projects, and I've noticed that we're not very good at talking about long-lasting software. We talk a lot about user experience, very important, reliability, security, performance. I mean, we go mental for performance, don't we? We love over-engineering it. I mean, we over-engineer the wrong bit, and it's still slow, but got to have some fun. What we don't talk about so much is how long we want our software to last. That is, how long it's to remain fit for purpose. So consider a common software application lifespan. Usually we get going on the project, it's awesome. You know, it's green fields, it's like Inception, just pure imagination space. The design's clean, it's great, rating features. And this goes on for a while. Eventually we'll get to the point where we release the first version, hopefully. And it's not quite as much fun now, because now we've got, real problems, real bugs. But it's kind of cool because it's being used in the real world. So let's take that point and fast forward a few years. Let's see where we are now. Maybe a couple of the original team members have left at this point. It's getting a bit harder to make changes now. We're getting new features coming in, but they don't really fit in with our original design, and the software's getting quite hard to maintain. Maybe some of our tech stack's no longer fit for purpose, and we're using a bunch of dependencies or third-party services that kind of hard to move away from, but also not kind of doing what we want. So no, at this point, no one really wants to maintain it or work on it. We warn off the new devs when they start. Stay away from that one. Or if you're as old as me, you try and lump them with it. So now we've fallen to the pit of technical debt. We'd love to rewrite at this point, but it's only a few years old, and it doesn't really make sense financially. It's a pretty common story, and I bet quite a few people here could relate. So this got me thinking about what we could do to prevent falling into the pit of technical debt. It's often too late once you're in it, right? And frankly, a few years for software isn't good enough. So I think some minor changes in how we build and design software can have some pretty major implications for the lifespan of our software. That's why I picked this quote: "An ounce of prevention is worth a pound of cure." Anyone hazard a guess who that quote is attributed to? It's kind of a tough one, but I'll give you a clue. He flew a kite in a famous experiment to get it struck by lightning. Benjamin Franklin. Nice. So when he wrote that quote, he wasn't talking about software. He was talking about fire safety. And he was talking about when you're carrying hot coals from one room into the other room in your warming pan, make sure you put the lid on, because an ember could jump out and start a fire in your house. So that was great, but I didn't have any idea what a warming pan was. Turns out, old school hot water bottle. So you put the embers into your pan and you slide it into your bed. And apparently the bit where you slide the hot embers into your bed, that's the safe part. Carrying them around without the lid on is the dangerous part. So if you guys remember nothing from this talk, always put the lid on your warming pan. So imagine if we transported someone from the era of warming pans to the present day. They'd be pretty interested in computers, wouldn't they? We'd have to explain how they worked. And I think if we explained software to them, they would think it was the longest lasting thing that anybody had ever invented, right? Doesn't wear out, doesn't make mistakes no matter how many times you run it, close enough, can be copied perfectly an infinite number of times. Then you'd have to break the news to them. You have to say, look, software applications don't last that long. I mean, 6 to 8 years is pretty optimistic these days. And that's very weird. But here's the thing, software's short-lived because it doesn't change. The world moves around software, and software doesn't know how to adapt. If you gave a person a job. They might do it a bit slower than software, but they're going to adapt when changes come in. The external world will change around them, and they'll know just how to adapt their process. Software doesn't know how to do that. So what does change around software? Well, business processes is a big one, right? Users demand more features. New technologies become available. Developers' ideas change, and users' ideas change, especially in the web space. I mean, we've got it pretty rough, right? JavaScript frameworks, for example, are pretty notoriously short-lived. In JavaScript frameworks' defense, that's not really true. They're not talking about React or Angular here. And I did read the article, and it's sort of like, talking about small JavaScript frameworks and averaging it out. But I still had to put the slide up, because if you look to the right, people also search for "I hate JavaScript frameworks." And the way this plays out in my head is that they searched for the lifespan, and they were so angry that they immediately had to search on that next. So we're not the first people to think about long-lasting software. There was a computer scientist called Manny Lehman who did a bunch of pretty well-known research in the 70s through to the 90s. And he developed laws on how software evolves by studying software applications that were being built. So the first thing he realized he had to do this was to divide software up into different classes, because they don't all behave the same. So he came up with this classification system, so S-type, P-type, and E-type. So just quickly, S-type or specification type is kind of like quite a closed problem, and you sort of know when you're done. So it might be you're writing a compression algorithm or something like that, and sure, you might need to optimize it or do a bug fix, but you're kind of done when you're done, and it's pretty long-living. The next type was problem type. So this is more tricky because it's modeling something in the real world. An example is something like modeling the weather. So I imagine, I've never done that, but I imagine it's incredibly difficult. But nothing you put in your software is going to change the weather, and nothing the weather does is ever going to impact your software. Which leads us on to the E-type. So they're the tricky ones. So that modeling a real-world process, there's no precise specification and it's changing. Even worse, your software is part of the process you're trying to model. So consider a booking system where people ring up to book a table at a restaurant and you replaced it with an online booking system. Users will modify their behavior because of your software, and you need to adapt your software based on their behavioral changes. So it creates a really interesting feedback loop where your software changes the business process and your business process changes your software. So the reason it's embedded is because it's embedded in that process, and that's the type of software that Lehman was interested in, the one that I'm talking about in this talk. So he came up with 8 laws describing how they evolve. I've distilled them down into 3, what I think are kind of useful for our purposes. The first one we kind of talked about, which software must be continually changed to stay fit for purpose. One of the things he noticed, for example, is user satisfaction will drop off unless you keep adding features to software. And as these changes are added, the complexity of your software grows, right? We're all too familiar with this. We often call it software entropy. I like to think of it as a force that's kind of pushing against us, and as Lehman said, you need to actively push back against that to keep your software simple enough to evolve. Think about things like refactoring your code, that would be a classic example. And the last law there, growing faster increases complexity, kind of speaks for itself, but the faster you're changing, the harder you're going to have to work. That force is going to push back against you even harder. In fact, Lehman goes so far to say the problems will cancel out the extra resource that you throw into a project. Consider throwing more developers into a project to speed it up. It brings with it some pretty serious challenges to do with the complexity of the software. Fred Brooks sort of popularized this idea in the mythical Man Month, which was a sort of mid-70s book where he talked about the dangers of adding developers into projects. Cool. So to design for longevity in these E-type systems, we don't need to design software that's so good it never needs to change. We need to design software that can change. We want to be able to replace and refactor parts of the system with a minimum of impact to other parts of the system. So I think software engineers are generally pretty good at doing this. We've got a lot of basic software engineering principles that are great tools for modularizing our system design. We know about things like separation of concerns, principle of least knowledge, so that this part knows as little as it needs to do about this other part. Designing clean interfaces, design patterns like dependency injection. So we understand about interfaces and making our software modular, but we really think about the change requirements of the different parts of our system. Ideally, we'd want all modules to be really cheap and easy to change. But reality doesn't really work like that. So we kind of get into the situation we want to make sure the ones that change frequently are easy to change, and the ones that are hard to change less. It's kind of I can't even read that out, so it's probably too hard to hold in your head. Consider a house and the difference between rearranging your furniture and changing the foundations. You want to be able to rearrange your furniture pretty frequently, and so it's easy to do. You don't want to change your foundations regularly. Cool, so I thought about a way to visualize this using a scatter plot. So in the y-axis, frequency of change, x-axis, we've got cost of change. So rearranging your furniture would be in the top left, and changing your foundations would be in the top right. You kind of want to avoid the top right quadrant. It's a bad place to be. So ideally, you want the modules of your system to be along one of the axes. So I've taken what I'd say a pretty common web application design. So we've got like a relational database with a back end sitting on top that queries it, provides an interface to the front end client, and maybe there's a message queue off the side which communicates with other parts of the other systems. And I took a stab at putting them onto the scatter plot. So try not to worry too much about the specifics of the breakdown or where I've placed them, but it should be indicative for our purposes. So if we were back in Inception land where everything's pure imagination, we'd take everything and slide it against that axis, so that all the different modules have their own ideas about how frequently they need to change, but it's super cheap to change them. Unfortunately, it's not that easy, obviously, but moving them to the left is always a good thing. So how do we move things to the left? We'll pick on one that we've already made fun of, front-end framework. So a change will mean different things for different modules on this chart. I guess in the case of front-end framework, I'm kind of thinking about maybe you want to replace it with a new framework, or maybe you've got some breaking changes and upgrade, or you want to do a major refactor, something along those lines. So the first thing to do is ask yourself a question like, how would I replace this framework in 3 to 5 years? I've just pulled a number out there, and the interesting thing is putting a time frame on a module kind of leads to a shift in your mindset. I mean, no one ever designs or write codes like that, do they? Despite all the evidence to the contrary, we assume this one is going to be perfect and never need to change. It's kind of like the program equivalent of going la 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 la. So we've snapped ourselves out of that mindset by putting an expiry date on this. Now we want to isolate parts of the system that need to outlive that time frame. So if we take a client-side framework, maybe we've got some validation logic that's quite complex and specific to our business. If we can isolate that, in this case it might make sense to just pull it out into a plain old JavaScript library and try and separate it from your framework code, your components. It's pretty common to put that kind of logic straight into your components. If we can go a step further and try and remove as many dependencies on that isolated part as we can, we're going to have something that's pretty easy to move around in the future. I mean, I'd be willing to bet if you had a standalone JavaScript library that depended on browser APIs or a minimal set of dependencies, you could drop into any framework in 10 years' time. So that's a front-end specific example, kind of a small one, but in summary, I think if you can isolate the parts of your functionality that are specific to your application and you want to be long-lived, and then try and reduce the amount of dependencies on them, you're in a really good place when you need to replace those kind of things in the future. Let's move over to the server-side language. So this is kind of quite an interesting one because I don't think you really can move this to the left. If you're switching your server-side language, you're kind of in for a big rewrite almost by definition. But what we can do is hopefully move it down a little bit. And to move things down, you kind of need to do a little bit more of that upfront design and invest your time into thinking about it. So in the case of a server-side language, you might try to make the best decision you have given the knowledge you have, invest a bit more time in that decision. Look at software language trends, for example. Discuss with your team and other developers. Do your homework, basically. You can see I've put client-side language right on the bottom because it seems to me JavaScript, for example, is probably, you can bet that was going to be in here in 5-10 years is a pretty solid client language. So last one to look at, I think, is one that could go either direction, the hosting provider. So it's pretty common now when we build applications to couple pretty tightly into like a cloud services and things like that. And I think what that does is it moves that thing to the right. So if you wanted to switch off that cloud provider, you're kind of in a bit of a tough spot. So you've got two options. The first one is you try and more loosely couple to those services. So you're confident that if push comes to shove, you can migrate off them and switch to another provider. Or you can say, we're happy with this provider, we've done our homework, we're comfortable with the pricing model, we're pretty comfortable that we're going to be sticking with this provider for a long time and move it down. So you've kind of got options. Now I think data model is kind of a special case. It's possibly one of the more contentious bits of advice, but I've worked on applications where we've done a lot of upfront thinking and design of the data model, like the entities and the relationships and how we're going to store them, and other applications where we've kind of been a bit more, we don't know what tomorrow's going to hold, so we'll evolve it as we go along and build it. And in my personal opinion, the ones with the upfront development, upfront design have come out on top. So there are a couple of quotes I picked that I think kind of help to explain why. And I think basically what they're saying is your data model is so fundamental to your application and kind of underpins so many parts of it, it's worth putting that upfront time into getting that stuff right because it has a really good flow-on effect through the rest of your application. I guess one more warning on this is like just be very wary of your tech stack trying to tell you how to store your data. I'm kind of thinking of opinionated ORMs here. You should store your data in a way that makes sense for you and your organization, not the way that your tech stack wants you to store that. Because really your data is probably the one thing you're never going to be able to replace in your application. So take care of it and protect it. So those quotes that I picked a minute ago, turns out they were about 2,000 years too late because this guy had already nailed it. Cool. So just talk a little bit about commercial off-the-shelf software. I'm kind of thinking about all off-the-shelf software here, but I think commercial is probably the worst offender. It's often cited as a really smart way to write code, and the benefits are very compelling. For example, you don't have to build your, just as a quick aside, it's like when you're taking probably a chunk of your application and kind of using a third-party service or another system to handle that. You don't have to build your own solution, which is awesome. It's generally really quick to get started. Someone else is managing your updates and upgrades. And they've probably thought through a bunch of problems that you're immediately going to run into, right, if you try and build this sort of stuff yourself. However, there are a few trade-offs that need to be considered. So whilst off-the-shelf software does increase initial development, it's been shown to pretty clearly to be like a big cause of software needing to be retired in the later parts of its life cycle. Basically what it comes down to is you don't have control over a part of your system. So when we're talking about the world changing and adapting, your software needs to adapt. If that part can't keep up with you, you don't have any control over it. They could decrease their quality, they could be unable to adapt, like we just talked about. Pricing model might change, they're no longer updating the software, or they just go out of business. So I like to consider the analogy of running a restaurant. Think about the difference between outsourcing the cleaning and the washing up versus outsourcing your food preparation and menu design. One of those you're probably going to be able to switch without too much hassle. One of them's totally going to change the character of your restaurant if you want to switch off it. So I'm definitely not advocating against off-the-shelf software. The benefits are real, but do it with caution. And try to do it for parts of your system which you're happy to give up control for. And if you do use one, make sure you've got an escape plan for how you can switch off that provider at some point in the future. Which leads me on to my next point, install escape hatches. So I'm not thinking about an ejector button on your desk, you're like, sort of fly away, or in a meeting room, that'd be great, wouldn't it? Someone asks you a tricky question. But, if your manager's going to sign off on that, you should totally get one. But what I'm talking about is basically an exit strategy for parts of your system. The off-the-shelf stuff I just talked about is probably a really good example of that. If you want to find a more compelling alternative, you just want to be able to remain flexible in switching off that kind of stuff. It doesn't need to be pain-free, but it needs to be doable. Might be as simple as just you using a third-party library and you just use an adapter pattern or a wrapper library or something like that around it because you think you might want to have the flexibility of switching off that at some point in the future. And a big one I've kind of talked about, but try not to lock into any proprietary data storage solutions unless you're very, very confident you can get your data out again. Cool. So they've talked about the design a little bit there. So just wanted to talk a little bit about building for longevity, sort of the things you do in an early stage of your, I guess, of a software application. Control your dependencies, because, I mean, was in Stevie's talk yesterday, and he talked about, like, was it 3 libraries with A-frame and how many times that got updated? You know, we're JavaScript developers. We know about big dependency trees and how painful that can become. So try and be discerning with your dependencies because they are a big cause of problems when software gets older. Try and prefer standard libraries where you can. I mean, it's as simple as sometimes they're not quite as nice to use or as elegant, but you can kind of guarantee they're going to be around. I mean, browser APIs are a classic example of that, right? JavaScript code that we've written way back when will still work today. Build in time to battle entropy. So if you remember, one of Layman's laws was kind of like, as you're adding features, the complexity is going to grow. Think about that, trying to push everything on your scatter plot to the right. You need to bake in time to try and push that stuff back to the left. And it's sort of too late if you just do this once your application's in maintenance mode. Kind of from day one when you start building, you need to be thinking about refactoring, upgrading dependencies, staying on top of that kind of thing. Maybe it's a couple of days out of every iteration. Maybe it's you take one iteration out of every 5 or 6 and use that as a refactoring simplification kind of sprint. I love the analogy of technical debt, and I think because it grows over time and you've got to keep paying it down. And once you're down in the pit of technical debt, it's really hard to climb out again. I mean, I know, I've been in there. And the last one is try and upskill your team members. So it's not really just making them better programmers. I mean, that's a part of it and useful, but it's more about making sure when you bring a new dev in that you align them with the design goals of your application. Remember Layman's laws, one of the other ones was that the more resource you throw at it, the quicker the complexity grows. I think a big part of that is the communication needs to be really good. But if people are on board and they're all pulling in the same direction, the amount that your stuff's moving to the right will be reduced. So talked about a fair bit there. Let's just go to the summary. So longevity is both really important, but it's also pretty hard to do. Software is short-lived because it never changes. So modularize your system. Put on that scatter plot and think about ways to reduce the cost of change for different modules. Move things to the left. If there's still things that are important, think about ways to reduce the frequency of the change and push them down. Invest in your data model. Be skeptical of off-the-shelf software and try and install escape hatches where you can. Build for longevity. Legacy software doesn't have to suck. And always, always use the lid on your warming pan. Thanks.
We do have time for a few questions. If you put your hand up, we can bring the microphone to you.
Hey.
Hi, awesome talk.
Thanks.
Talking about data models, I 100% agree, super important. What do you do in a case when a data model was defined a long time ago when at the start of a business,
Yep.
and you're at a point where it's basically making any current decisions and designs extremely hard.
Yes.
So it's obviously it's kind of time to revisit it and redesign it, but
Yep.
you've already built there's so many systems that are used and very coupled because of the data model. So how do you go about convincing people that it's time to move on?
it's a really tricky situation to be in. And I think it's kind of why I'm advocating try and invest that time to reduce the problem as much as you can before you get there, because frankly, I don't have a good answer for how to get out of those kind of problems once you're in them. I think every diff system has kind of got its own set of challenges that it's kind of hard to give a general answer to that kind of stuff. But I think you've just got to make a trade-off. You've got to use your judgment. Is it worth trying to change that data model? I think if you can do it and the business is willing to throw enough money at it for you to do that, which is really the tough part, the benefits are real. So, one thing we try and do is really sell the business on the future dream of having an increased development speed. And they all often get that and sort of agree to some of the refactoring changes. But yeah, it's a tough one. It's hard. If someone wants to give that talk and explain to me, I'd love to hear it. Yeah.
Questions?
Oh, yes. Thanks, that was an amazing talk.
Cool, thanks.
What resources do you suggest on learning how to data model really well?
Yeah. I don't really feel qualified to pull some out, really, but there's a lot of information about it. I think where I learned was a lot around like schema design and things like that, and I think it really gets you to think through. If you can find like a database expert or DBA or something, if they still run, and get them to explain a lot of that stuff to you, they're a really good resource. And there's a lot of great information out about that sort of stuff. It's a pretty, classic topic. So, yeah. Sorry, I don't really have a good answer to that. Yeah.
More questions? In the back, perhaps? Is there one down here?
Hi, thanks for the great talk.
Cool.
So, my experience started when people advocated for data modeling first, and then I sort of transitioned to code first. And now it seems we're going back to data first. Where exactly do we strike a good balance?
Yep. Yeah, that's a really good question. And I mean, it's kind of frustrating, to be honest, throughout your career. You see this kind of gradual sort of cycle. I think the thing to always remember is that none of this stuff is like a rule that you always need to follow. End of the day, software developers' job is to take all the information that you've got and try and use your judgment. So sometimes it makes sense, and some projects it won't make sense. Maybe you don't know enough to define your data model really explicitly. I think it's probably gone a little bit too far the other way at the moment, where I think the upfront design does pay dividends and we can do a bit more of it. But I don't think you should ever take it to the extreme, where it's like that this is the one true way to do it and we're going to always do this. Yeah, so I guess every application is its own unique bundle of joy, and you need to use your judgment about the best sort of stuff, the best way to do this. So I think it's a general reminder that doing the data first is, in my experience, really been beneficial. I've never regretted doing that. Yeah.
Okay, I think that'll do. Let's give Ewan another hand.
Cool.